In previous lessons in this series, we've been looking at how to write the names of formulas and how to write the formulas for names for compounds. We've been also looking at bonding. But we're going to continue our discussion today on how to write the formulas and names of ionic compounds. And then we'll transition into how to write the names for some simple acids. Okay, so what's at the bottom of this page is the homework number 1 that I gave you yesterday. And we're writing all the formulas and names for compounds of chromium and phosphorus. If you look on your periodic table, the large main periodic table, chromium is right here. If you go to the periodic table that has oxidation numbers, you'll see that chromium has 5 different oxidation numbers, 5 different charge numbers. So we're going to list all 5 of those. So 6, 5, 4, 3, 2. Okay, now if you are not talking about chemistry, be quiet. Let's focus on what we're doing here. And so phosphorus is located right here. If I add, this is a nonmetal, it's going to tend to want to get extra electrons to have a full valence level. So for that, then it's going to need 1, 2, 3 electrons to fill its valence level with electrons. That would give it a 3 negative charge. Over here, you can see that phosphorus has 3 different oxidation numbers. Only one of them is negative. Since chromium, all these chromium oxidation numbers or charge numbers, are positive, this has to be some kind of negative number. That's the only way you're going to get a neutral charge overall. So we're going to make this 3 negative here on all of these. It's the only one that's possible. What we want is a compound that has a neutral charge overall. Okay, so if I have a 6 plus here and a 3 negative here, and if I show that there are 2 of these, now I have 2 particles with 3 negative charges for a total of a 6 negative or 6 negative charges here that cancel out the 6 plus. That would give me a formula of CrP sub 2. Okay, now what is really important is that you get this final answer and get it correct. That you do all this other stuff the way I did it is not as important. This is important. So I'm giving 1, 2, 3 points for this. Alright, now this one has a 5 plus charge and a 3 negative charge here. The only balance that's going to get this to be a 0 charge overall, the only ratio of chromiums and phosphoruses here that are going to give us a balanced or neutral charge is if I have 3 of these and 5 of these. So we're going to have Cr and a sub 3 on the Cr and a sub 5 on the P. And that's going to be worth 4 points. 1, 2, 3, 4. Alright, so this one I need 3 of these and 4 of these. So there's 1 and 1 of these, so that's the correct formula there. You only need 1 and 1. We need 3 of these and 2 of these to make this balance out, so we're going to need 3 here and 2 here. Alright, this one is going to be worth, I haven't put the numbers, the lower numbers here, 3 and 4. That's 1, 2, 3, 4 points there. 2 points here, 1, 2, 3, 4, 4 points here. All right, for the names then, this is chromium 6, phosphide. There should be no space here, but there should be a space here. I really should have moved that up a little closer to that M on this. I will do that on this one. So there's no space here. This is chromium 5 because of the 5 plus charge on the chromium. Phosphide. Chromium 4 because of the 4 plus charge. Chromium 3 because of the 3 plus charge here. And chromium 2. So for the names then, the word chromium is a point. The parentheses, both front and back, make up a point. The Roman numeral make a point. Phos, or phos, pH, is a point. DE is a point. Excuse me. 1, 2, 3, 4, 5 points. So all of these are worth 5 points here. So when you add up all the points on this set of problems here, this is worth a total of 42 points just for this section. So while we're talking about chromium, there's this movie, which was famous at its time anyway, called Erin Brockovich. It's about a real person. And it was about a chemical company causing problems with the health of people in the community because these chemicals were getting into the water. Adib, you don't think this is important enough to listen? So they were discussing the problem was with chromium in this movie, and they were talking about hexavalent chromium, and I think it was divalent chromium. Okay? And the difference between the two is exactly what we're looking at here. Hexavalent chromium is chromium 6, and it's either tri or divalent chromium will be 3 or 2. So if you ever watch that movie, there's the chemical connection to what you're learning right now. That chromium 6 is hexavalent chromium for 6 valence electrons being used in the bonding for that chromium ion. Okay? Just thought you'd like to know that. All right, so problem number 2 is to write all the formulas and names for a combination of all the ions of molybdenum and periodate. Molybdenum is one of the 3 stooges. There are 3 different oxidation numbers for molybdenum: 6 plus, 4 plus, and 3 plus. Periodate, you look it up on the periodic or the test references and find the common ions list and find periodate. Periodate is right here. It's iO4 with a 1 negative charge. And so if we put this molybdenum together with iodate, we're going to need 6 iodates. Put this molybdenum together with this iodate, we need 4 iodates. And this molybdenum with this iodate, we need 3. Okay, so let's see. Each of these formulas are worth 6 points. 1, 2 for the parentheses, 3, 4, 5, and the 6 down here is a point, so that's a total of 6 points. 1, 2, 3, 4, 5, 6. So all these are worth 6. The names then, this is molybdenum 6. The Roman numeral needs to be right up against the name, but there's a space between this name and the second part of this, per IO date, and this would be molybdenum. Oh, not eon, but That's molybdenum 4. And this is molybdenum 3 because of the 3 plus charge. So molybdenum 6 is molybdenum 6 because of the 6 plus charge. Molybdenum 4 is molybdenum 4 because of the 4 plus charge. Now molybdenum 3 is molybdenum 3 because of the 3 plus charge. Alright, molybdenum is worth a point. The Roman numeral, the parentheses around the Roman numeral is a point. The Roman numeral is a point. Per, the prefix per is a point. The middle part of the word IOD is a point, and 8's a point. So that's 6 points for each of these. So it comes out to be 36 points for this part of the problem. And all the points for the complete homework then is 78 points. So when we have lead 4, it means lead with a 4 plus charge. Carbonate you look up on the common ions list. That's CO3, 2 negative. And you're going to put it together to be Pb, CO3, and 2 of those, because you're going to need 2 of these carbonates with 2 negative charges to balance out the 4 plus charge. Okay? This 2 comes from the need to have 2 carbonates, because they have a 2 negative charge, to balance out or cancel out the 4 plus charge. We need a compound that has a neutral charge at the end. Then, conversely, if I give you this formula, you have to be able to figure out the name. Okay? So what you're going to do is break this apart. You're going to undo this problem. So this one went this way. We're going to take this down here and go the other way. Okay? That's an S. Well, you're just breaking it up. Now, you have to be able to recognize polyatomic ions. You have to look at this formula and say, oh, there is a polyatomic ion. I need to look up its name and its charge. Are you paying attention? Because if you're doing other things and not paying attention to this and you get it wrong on the test, that's on you guys. All right? Here's an SO4. All right, we're going to look over here at the common ions list and find that grouping. Anytime you have more than 2 elements, one of the first things you need to do is to go look for a polyatomic ion on the common ions list. Anytime you have more than 2 elements, you need to start looking on the common ions list for a polyatomic ion. It may or may not be there, but that's what you're going to look for. Okay, you got to think to yourself, oh, more than 2 elements. Ding, 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 ding. I need to look on the common ions list, okay? That is sulfate. Sulfate's located right here, okay, and it has a 2 negative charge. So, How many sulfates are there in the formula? How many sulfates are in this formula?
4.
Really? 4. Okay. So how many total charges are represented by this part of this equation?
Is that a lowercase o?
That's a capital O.
Wait, sulfate is 2 negative.
I have a 2 negative. So the question still is, how many charges, or what kind of charges, what total charges and how many are there, what kind of charge and how many are there represented by this 4 sulfates? 8 what? 8 negative. So this represents an 8 negative charge because I have 4 of these particles that each have a 2 negative charge. And SO4 is considered a particle. It's a covalently bonded group of atoms with a charge. That's what we call a polyatomic ion. So this 4 right here means there are 4 sulfates in this formula. What? If I were asking you to give me the name of this, then I would be giving you the formula first, okay? Depending on the problem. Now, if I have a charge of 8 represented by these 4 particles, what charge does this 1 ruthenium have to have? 8 positive. Very good. It has to be not just 8, but 8 positive. Okay? These are not just numbers on a number line. These are actual charges. Okay? So then, what is the name of this ion here? Ruthenium 8. All right, now here's the thing. You've got to ask this other question too. Where is ruthenium? Is ruthenium in the first column where there's only one kind of charge? Because we don't need Roman numerals if it comes in this first column because they all have the same charge. Is it in the second column because they all have the same kind of charge? We don't need Roman numerals if it's in the second column. Or the third column, we don't need Roman numerals here. We don't need Roman numerals for the first 2 elements in this column 2b, and we don't need Roman numerals for the first 4 elements in column 3a. Okay, because all those have the same charge, exactly the same charge all the time. It's only when you have multiple oxidation numbers that you have to have a Roman numeral in the name. But ruthenium is right here, and it does have multiple oxidation numbers. So we have to be able, when we write the name of this, we have to write the name of ruthenium with the 8 plus charge. Okay? There's not just one kind of ruthenium, there's more than one ruthenium, so you have to state what that name is, okay? So when we write the name, then we're going to write ruthenium 8 sulfate. Okay, now sulfate, we spell it in the United States with an F. Most of the rest of the world spells it with a PH here instead of the F. Okay? Here's another example. I have more than 2 elements. I have more than 2 elements here, so I need to look and find if there is a polyatomic ion somewhere on that list of common ions. Okay? This is carbonate. All right? Let's break it apart. All right, we've got PD. Okay? And we've got carbonate. Now, if you look on the common ions list, you should be able to find the charge on that carbonate. 2 negative. This formula shows only 1 PD, palladium, and only 1 carbonate. So what charge must there be on this PD? 2 plus. Does palladium have more than 1 potential oxidation number? Okay, then we must name it with the Roman numeral. You got me? So this is going to be palladium 2 carbonate. Got it? Okay, write the names for these compounds. Now, okay, so we're going to have some, I guess, guest teachers here, all right, that are going to try to solve these problems for us and show you the solution. Your job in the audience is to listen, pay attention, be respectful, and help if it's needed, okay? We're doing the baseball analogy. We've got one person in the batter's box doing the work and one person on deck. So when the person who's in the batter's box now walks away, the person on deck goes up to bat, the next person goes to the on deck circle. All right, ready? Let's go. Play ball.
So you want me to teach it and everything, okay?
Yes, explain it when you do it.
All right. So, of course, you see, you just, oh, the table keep moving, messing me up. You're going to break it down, so you just put NB plus ClO3. Let me use a pen, I got you.
Well, the thing is about using a pencil. With a pencil, you can tell if there are mistakes and erase them. Yes, you can use a pen, but it's harder to fix the mistakes.
You got white out.
Yeah, but it's hard. You can't write over white out.
Just bear down harder.
Just bear down harder?
That's okay, Pat. Stripes.
Is that better? Can y'all see that a little better?
Yeah, a little bit.
Alright, so you see here, you have ClO3, and you have 5 of those. So if you have 5 of those, put it on the left side of it and put these in parentheses.
All right. One correction here. If the only reason we need these parentheses here is because there's a 5 outside. Since I'm putting a 5 in front, I don't need the parentheses here.
You don't? So you would count off of that?
I would on a test, yes. Okay. So listen. When you have a polyatomic ion and there are 5 of them with a large letter 5, or large number 5, out in front with coefficient position, then you don't use parentheses to show there are 5 of those. Okay. Got it? All right. Go ahead.
Oh, and then you, make sure I got this right. Okay, I look for this in the chart. In that chart, what is it called? The
Common ions list.
common ions list chart. And so it's ClO3 negative. And so you look at that, and so 5 times -1, that's going to be -5. So what plus -5 equals 0? +5. So that's how you get your NB.
You don't need an arrow here because that would
Oh, you
indicate
don't?
something else.
Oh, never
I
mind.
mean, I probably wouldn't count it wrong, but that we use arrows to indicate there's a chemical reaction.
Oh,
Here
okay.
you're just naming it.
Okay. And you look at NB, that's I hope I spelled it right. Palladium.
No, palladium is PD. NB. What is NB?
Oh wait, no, niobium. I'm looking at the wrong thing. You got 5 exponents, so 5 is the top number, so that's 5.
No, we're not being respectful.
Hey!
It's this way.
Are you the teacher? Okay. Boom, bam.
Is he missing anything?
What am I missing?
What's he missing? No, he's got to put parentheses around the Roman
You
numeral.
right. Boom.
All right.
It's on my paper. It's just not on the.
All right. I'm not making you change anything, but let's just be clear about something. There's no space right here,
No space.
but there is supposed to be a space here. This Roman numeral is attached to the metal name, and this should be a space here, okay? Everybody clear? All
I
right.
know all that.
And listen, you only capitalize the names of compounds when they're like a title or they're the first word in a sentence. Those really shouldn't be capitalized, okay?
I was just gonna write down the. I'm not good at it. I am. This is how I write with my paper turned like this. Okay. Can you not complain?
No, nothing but farm on the way here. Yeah, like farm. Sounds like. Like this one dude that's like, wait, about this? Yeah. No. This is my mama's. Now, if SSU is playing, I'll be there. SSU.
Okay, I'm done.
Yay, congratulations.
I'm not good at explaining.
Where'd you get the
Well, it doesn't matter whether you're good or not, you gotta try.
Okay.
Where'd you get the 2 plus from? Because I got 6 plus.
I got 6 plus.
Where you been at?
Okay. See, they got different answers. So I got 2 plus from.
Well, we all got 6 plus, so I think.
Okay, how many sulfates are there?
3.
3 sulfates. You put a 2 in front of that sulfate. You need a 3 there. Okay? So
erase
change your
this?
2 to a 3. No, not the charge. The number in front, the coefficient number.
I
The
do.
2 was correct. The 2 negative was correct. All right, there's a 3 out in front. All right, if I have 3 sulfates, they all have 2 negative charges. How many negative charges total are there?
6 negative.
6 negative.
So that's supposed to be a 6
So
plus.
what charge is tungsten? If there's only one tungsten, what charge does it have to have?
6 plus.
So you multiply.
Now, change your name of the element to reflect, or the ion to reflect that
You talking about
number.
this?
Yeah.
It'll be a 6.
How you? I don't even know how to write
It's
that.
it's like a 1 and then a V.
All right, look.
Oh,
Y'all
this?
have got to be more respectful.
Yeah.
This is not working if you're
I
not paying
mean,
attention.
the V and then the 1. Correct.
Yes.
What I was gonna do.
I didn't get it.
What now?
I know where you get the negative 2 3. But do you just multiply?
Who's the next one up? You gotta be in the whatever this thing's called.
Say again.
How do you get it?
Watch, I'm gonna write this in pen because I'm gonna be right.
3 times negative 2 give you negative 6.
Thanks, Chief.
You didn't add anything. 5 times a negative
I'm gonna throw this pen at your forehead.
4 times negative 2 is 8. And then you add this and this. Alright, guys, now listen, you are not, look, we're not going to do this, and people are going to lose the opportunity for extra credit if you can't focus more and pay attention up here and be respectful, guys. Come on. This is a learning opportunity for you. If you're not paying attention, you're not learning. Okay? They're your teacher right now. You are supposed to be supporting and helping them. All right? Now, that's good. One thing, on the previous problem, this problem is fine. On the previous problem, she capitalized the letters again. You really shouldn't capitalize letters.
I got you.
Unless they're part of unless they're the first thing in a sentence or they're a title or something, okay? So don't capitalize letters, all right? All right, she's going to fix that for everybody. Okay. Next batter.
I'm still right here.
I know you are.
I'm still.
You got struck out once.
Actually, I got a home run. Thank you. Okay.
She thinks she owns it.
I do know.
The compound name on the second one, what's that?
Sulfate.
No, that's why he's not.
Too bad I got number 3, 2, and 1 right.
That's why I got all of them right.
That's why you just copy it and then transfer it.
Too bad.
Wait. Oh. Do I even put a charge? Wow. The Roman numerals.
Morasia. Talk about next semester another time.
I still have to put it even though it's 1? There you go.
The most appropriate response is yes, sir.
Yes, sir.
Thank you. All right.
Is that right?
1, sulfate. Yeah, you should have a space between the Roman numeral and the second word. Okay, that's okay. Just know that it's supposed to be there, okay?
Okay.
All right, next person. Let's go. Yes.
Why is it like CU parentheses? Why would you do that so you would know it's through a copper? Like CRT. I thought it was like CR.
For number 4?
Yeah.
All right, for number 4, you say copper 1 because the Roman numeral tells you the charge on the copper. You in your head have to figure out how to balance it from the formula, okay? Or in the formula. So if copper 1 is bonded with sulfate, then you're going to have 2 coppers to balance out sulfate's 2 negative charge. Okay?
You don't put it in Roman numeral because it's
Exactly.
in the first
That's
and two.
right. She's right.
It's in
Since
the.
strontium doesn't have any more than 1 oxidation, it only has 1
That's right,
oxidation
sir.
number. And we don't use a Roman numeral. It's in column 1 of the periodic table.
Thank you for explaining. I just wanted to
On column 2, I'm sorry. It's in column 2 of the periodic table. There you cannot use a Roman numeral when it only has 1 oxidation number. Okay? Well done. Good job.
Sounding both.
All right, now these are the tough ones here. All right, I gave you a couple of ringers.
You might have a problem getting up here.
All right, you can stand if you want to.
Nope. Yep. We can't do that. We
All
can
right.
stand. Okay.
All right, she's going to try to name these monsters here.
Yeah. Let's do that.
What? I want to give you credit for it. You can keep that because it's used for maybe getting treatment or something later.
How early did you get yours? How early did you get yours?
Huh?
What time did you get your birthday? No, it's not even I tried to. We're at 7:53.
Guys, y'all got to be more quiet. What? What?
They don't like you. Oh,
Right out of room, who?
you said 7:30. Why are you lying?
Well, I got.
Okay.
You hear that, Mr. Taylor? At 7:30, and he got here at 7:40, and they let him go in there.
You what?
That's messed up.
Well, they finally brought, like, right over I got there, they were bringing
Let's worry about this another time. Focus on the problem, okay? Because you're supposed to be learning from this. Just because somebody else is doing the problem doesn't mean that you aren't responsible for it. Okay?
Is that right or wrong?
Isn't that supposed to be a hexavalent? Is it 2? Yeah, I'm sorry, it is 2. You're right, it is 2. I don't know. All right?
Wait, let's look over it first.
Okay, look over it. If you want her to explain it, I'm sure she can.
Yep.
Okay? Somebody asked you to explain.
Okay. So, we have, let's see, what's the, let me find it. Right here. FeSCN, it's a 2 plus. So, let me just put this up there. It's a,
Well, yeah, you might have to put one up at a time. Okay, there you go.
there we go.
All
There
right,
we go.
that'll work.
Hey, I figured it out, yeah. But this is a 2 plus, so, and since there's 3 of them, it'd be 6. So the second part, since there's 2 of this, and there's 2 types of this, right here, it'd be this one because 3 times 2 is 6, and not 4. 4 times 2 is 8, and it has to be 6 and 6.
Let's do this.
Oh,
It's not that bad, guys. It's not that bad. We're going to make some folds here so you can kind of see everything a little bit better, maybe, okay?
okay.
How about that? Pay attention. All right. Show them again where you got the FeSCN. It's right to your finger there on the screen.
FeSCN, it's actually under the polyatomic cations.
And it's a cation because it's positive.
Yep. So it's a 2 plus. 2 plus, if that entire thing is 2 plus, times 3. Because there's 3 of them. That would be 6. So this first part is 6 plus. Second part is FeCN6. Well, there are 2 of them. One here and one here. You have to determine, since there's 2, there's 2 of these, I have to see which one would multiply to equal 6 negative, which would be this one. So that would be 6 negative. So 6 plus 6 negative, 0.
Yep. That's where she got her name from. The Roman numeral 3 is part of the name for that second ion. Let me tell you. Oh, what's that?
If it's 3, it has 3 on the outside of those parentheses, so when it's Roman numeral 3.
No, because 3 is how many there are. 2 is what you put in the Roman numeral because it has a 2 charge.
Let me point out something here because there's 2 different 3s here. There's a 3 here. Guys, pay attention. There's a 3 here, which tells you how many of these you have. There's a Roman numeral 3 down here. And it might be a little confusing because what does that Roman numeral here and here apply to? It applies to the ferro part. So there's an iron in both of these ions. Okay? So this is iron 3. This ferro is iron 3. This ferro here is iron 2. And down here, this ferro is iron 2. This ferro is iron 2. Okay? 2 different ions with 2 different types of iron. Got it?
Yes.
All right. Everybody good? about those? All right.
Wait, don't.
Don't take it off yet? Okay. I promise not to. Okay, so here's your first homework. First homework, because we've got something else to learn before we're done. We're going to start learning about acids in a moment. All right, we're going to move on to acid nomenclature. Okay. Now, there are different kinds of acids named and written, the formulas are written in different ways in different classifications. And there are two major classifications of acids as far as nomenclature is concerned. One is a non-organic acid, and the other is an organic acid. Now, we're not going to, in this class, in this level of class, learn to name organic acids. So all the acids we are going to learn to name are non-organic acids. It's all sometimes called other things like physical acids. Okay? So we're going to be naming non-organic acids. Okay? And for all of those, the way that you're going to know from the formula that it's an acid is that it has an H on the front, or more than one H on the front. Now the general exception is, and it's only a partial exception, is water. We know that water is neutral. You should know that by now. Water is generally considered to have a neutral pH. And so up to now, you've been taught it is not an acid and it's not a base. In fact, later in this semester, when we get to the acids theory unit, we'll find out that water is both an acid and a base. It's contextual. Okay? It's called a universal solvent, right, for a different reason. Okay? We'll learn about all that stuff. Just hold on. Now, so if I have an H in front of something else, like this, well, that tells me right away that's probably an acid. Okay?
Why?
Because it has an H in the front.
What does the H have to do with hydrogen?
Because it's the hydrogen that does the work of an acid. And hydrogens have a low electronegativity. So if we're writing these in terms of where they are on electronegativity, we're going to put the H before the Cl. Okay? Because it has a lower electronegativity than Cl does. Okay? Now, we're not going to get into the theory of why acids behave the way they behave. We'll do that in another unit later in the year. Right now, we're just going to go about learning how to name these things, since that's what we're doing right now. Now, some acids are actually covalent in their pure form, but they become ionic or behave like ionic when you put them in water. Some acids are ionic all the time. They behave like ionic compounds whether they're in water or not. Okay? This acid is one of those that behaves like a covalent compound when it's not in water, and it behaves like an ionic compound when it is in water. So we have to treat that as kind of a separate category, different from covalent and ionic. But the way that you name these, anytime you have a non-organic acid, every time, anytime you have a non-organic acid, you always name it first like an ionic compound and then change the name. Always name it like an ionic compound first and then change the name. If I'm naming this like an ionic compound, what would I call it? Hydrogen chloride. Okay? I'm going to name it like an ionic compound. Now, in the category of acids that we say are non-organic, there are two major categories for naming. One category has monoatomic anions. So the anion is the negative part. So there's the hydrogen in the front, which is considered to be the cation, and the Cl in the back, which is the anion. Positive is anion, negative is cation. Okay? If you have a monoatomic, meaning a single atom anion, then there's one naming system we're going to learn right now. We're starting out with a chloride. Okay? When we have a monoatomic anion, then the hydrogen gets abbreviated and we get rid of the gin. Okay? High school students shouldn't have anything to do with gin anyway. Just saying. Okay? So it becomes hydro. Alright? Now, yes, but that's a different kind of gin. This is spelled differently than the one you're supposed to stay away from. Okay, this is This gen refers to all the genies that exist. Okay, now, and that's not what we're talking about here, right? Not a little joke. Yes, okay. Now, hydro, and then we're going to push this hydro. This becomes a prefix that's pushed up against this chlor prefix over here, hydrochlor. But the "ide" ending becomes "ic." Okay, so hydrochloric, and then you have to put the word acid on here. All right?
Oh, I get it.
Good. All right? So now, here's one for you to try. Name this acid. Name this acid. So what's the name of this compound?
Hydrochloric
Hydrosulfuric acid.
Just hydrosulfate.
Just hydrosulfuric? So no two?
Now, listen. Shh. You guys are being disrespectful. I don't appreciate it. I've been talking all day long how you got to turn the volume down. You can work together fine, but if you're chatting about other things, you're being disrespectful. Okay? You're also not learning effectively. You can expect me to start writing people up for that. Just saying right up front, okay? All right, now, the only thing is hydrosulfate kind of sounds a little bit cumbersome. When we have sulfur and phosphorus, when we're building the acid names, we put an extra syllable back on. So instead of hydrosulfic, we're going to call it hydrosulfuric, okay? Because it just sounds better. We're going to put that UR suffix back on there, okay? So we're actually going to call this hydrosulfuric acid, okay? If I had a phosphorus, which became a phosphide, then we put that OR back on there. So phosphoric instead of phosphate, okay? But those are the only ones we do that with, just because it kind of sounds better. I guess that's why we do it, okay? Since we're starting off naming this like an ionic compound, we would call this hydrogen sulfide. We don't use the number 2 at all because it's an ionic compound. So we name the acid, we also don't use that Roman numeral 2 or anything. And we don't use any prefixes like dihydro or something.
So
That gets in covalent compounds.
So it's just kind of like a trick.
Well, it's not a trick, it's just the system we use for acids, okay? Y'all got that?
Yep.
All right then, yes, homework. Here we go, homework number 2.
So number 1 is not number 1.
Well, this is number 1 in homework number 2. You got homework number 1, 1, 2, 3, and so forth. Now we got homework number 2 with 1, 2, 3, and so forth. This is the second of 2 homework assignments, yes. Both associated directly with the things that we learned in class. Hydrogen in column number 1 of the periodic table. So like the metals in column number 1, it's going to want to give away 1 electron. At least in an acid formulation it does. If we go over here to the periodic table with oxidation numbers, you can see it has a 1 plus and a 1 negative charge. When it behaves like an acid, when hydrogen's in an acid, then it's going to behave like the metals in that it's giving up 1 electron and therefore having a 1 positive charge. Okay, now listen, this is important too for you to understand in terms of what we're going to learn later in the semester. Because if hydrogen gives away 1 electron, I want you to think about this. What subatomic particles make up the structure of hydrogen? What subatomic particles are there in a regular hydrogen? Nobody's listening. Nobody's trying to answer. People are looking at their cell phones. I'm writing up people with cell phones. I will not give you notice about that now. Okay, I've already done that. Apparently, just my warning is not enough. Huh? Well, yeah, picture of the homework's fine. That's not what I'm talking about. Okay? When the cell phones are distracting, that's a problem. So, what makes up the structure of a hydrogen? What subatomic particles are there in a hydrogen atom? There's just 1 proton. Look at the atomic mass over here. Okay? 1 proton and 1 electron. If hydrogen gives up 1 electron to have a 1 plus charge, what's left? Huh? If hydrogen is made of a proton and an electron, or most hydrogens have just one proton and one electron, and that hydrogen gives up one electron to make it have a positive charge, what's remaining? Just a proton. So listen carefully. Listen carefully. A hydrogen ion is a proton. A hydrogen ion is a proton. You got that? That's important conceptually for you to understand. Okay. In our next lesson, we'll continue looking at how to name acids. We'll get into naming those oxyacids.